In this video, we're going to look at some additional examples with functions in Python. So particularly, we're going to develop solutions for three computational problems. And as we go through the solutions, the development of the solutions for these problems, I want to encourage you to write the code and make sure you could run it and experiment with it. So before we get started with developing the solutions, we need to think a little bit about what we need in order to write a function. So first thing we need to keep in mind is that a function should really do one thing and one thing only. If a function is doing more than one thing, then it's probably a good idea to break it up into two different functions. Okay, now the second thing we need to think about is what are the inputs to the function. So these are what we refer to as parameters. So we need to define what those are for a given function. And number three is that we need to think of the process for producing the correct result for a given input. So this is where all the computational thinking goes, the problem-solving aspect of the problem. And then finally, we need to define what the function returns, if anything. So the first problem we're going to look at is familiar to you. That is to compute the distance between 2 points given their coordinates x1, y1 and x2, y2. And here the only difference is that we're going to express that as a function. So what's the outline of the solution? So this is pretty straightforward. So the first thing is that we need to decide what to name our function. In this case, we're going to go with compute distance as the function name, but you could come up with other meaningful names. And then, it seems pretty evident that the inputs, in order to compute the distance between 2 points, we need to provide the function with the coordinates, and those are the x and y coordinates for the 2 points, and we're going to call them x1, y1, x2, y2. And then once we have these inputs, we can apply the distance formula, and then finally we return the result to the caller. So let's see what that translates to in terms of code. So here we have function compute distance, and these are the four parameters, x1, y1, x2, y2, and the distance function. The distance formula is x1 minus x2 squared plus y1 minus y2 squared, and that whole quantity we take the square root of. And in this case, we save it in this variable distance, and then we return distance to the caller. So let's see. So let's run this, and this didn't produce any output as expected because we're just defining the function. And here is some code to test this function. So what we're going to do is have 4 input statements to get the coordinates for the 2 points. And notice in this case, we're going to name the variables x_1, y_1, as opposed to the parameters which are x1, y1, x2, y2. So there's the underscore in here. And then once we have the inputs, we could call the function compute distance and send it those 4 variables as arguments, and x_1 is going to correspond to the parameter x1, and y_1 corresponds to y1. So this is to highlight that there is no requirement that the argument necessarily has to have the same name as the variable. So these could be arbitrarily named, but it's also okay to name our arguments exactly the same as the parameters. Okay, so we call the function, it returns distance, which we store in the variable dist, and then we have our print statement, which outputs the result, formatted output. So let's see what that looks like. If I were to execute this, I'm gonna input 1 and 1 for the first point and 3 and 3 for the second point. So the distance between those two is at the square root of 2 squared plus 2 squared, so that's the square root of 8, so that's the 2.8 over here. So that should be the square root of 8. Okay, and then you can try it out with different points as you wish. Okay, now the second problem we're going to look at is to determine if a string is a palindrome. So let's first define what a palindrome is. So palindrome is simply a sequence of characters that reads the same way backwards as forwards. So here are some examples. So if we take a word like madam, if we read it from left to right, it reads the same way as right to left. Same thing with civic and race car. Okay, now it's also possible to have a string that corresponds to a phrase as a palindrome. So for instance, a string like never odd or even, the sentence never odd or even, if you are to ignore the spaces, then it reads the same forwards and backwards. But technically speaking, we're not gonna remove the spaces, so this technically wouldn't count as a palindrome for our purposes. But if you wish, you could modify the program to deal with cases like that. Okay, so how would we approach this problem? So suppose you're given a string like race car, which we know to be a palindrome. So here's race car represented as a string, and the values underneath it are the indices starting at 1, going all the way up to 6. The string has 7 characters, so the index of the last character is 6. Now, the general approach to solving this problem, and this is just one way of going about the problem, is to start by examining the first and then the last character of the string. So we're going to compare those two characters and ask the question, are they the same? And if they're the same, then we're going to compare the second and then the second to last characters. So we're going to, the corresponding characters, so we're going to move in this direction from the front and in the opposite directions from the back and compare the corresponding characters until those two meet. Now, the way we're going to keep track of which characters we're looking at a given point is using two variables that store the indices of the characters we're looking at, and we're going to call them front index and back index. So initially, front index is going to be 0, and then the back index is 0. So that's when we compare the R to the R. And then if those two characters are the same, then we increment front index by 1 and decrement back index, so it's 5, and then we compare those characters. So we keep repeating this process on as long as that front index is less than or equal to back index. Now, so we could carry this a couple steps further, because it's a relatively short string, so this is going to be 2, this is going to be 4, and in this case, we take this one more step, this is going to be 3, this is going to be 3, and that's equal, E is equals to E, and since front index is equal to back index, then we know we're done. Now, if the string had an even number of characters, those two will cross. Okay, so you could check that yourself. So at some point, back index will be less than front index, but for odd number of characters in a string, they will meet at exactly the same index. Okay, so if all the corresponding characters are the same, then we know that this is a palindrome. So in this case, the function will return true. So this is the first example where a function returns a Boolean value, not a numerical value. Now, can we perhaps look at a case where it's not a palindrome? So let's suppose, to begin with, the string that we're dealing with is race cat instead of race car. So we start out by front index being 0 and back index being 6. And now we do the comparison between the two characters, and if they don't match, then we immediately know that this is not a palindrome, so we could return false. So there's no need for us to proceed any further than that, because it doesn't matter if all the other characters are matching. As long as we have a single mismatch, we know it's not a palindrome. Okay, so let's see how that translates to code. Now this is a little involved, but I think you could follow along. So here we have our input S, that's the input to our function pal, which is short for palindrome, and then we're going to initialize the front index to 0 and the back index to the index of the last character. Now the index of the last character is 1 less than the length of the string. So if we look at the previous example, or the example we looked at a little earlier, race car has 7 characters. The index of the last character is 6. So that's len minus 1. And then the terminating condition is that as long as the front index is less than or equal to back index, so essentially as long as they haven't crossed yet, we're gonna perform a comparison for the corresponding characters, S at front index versus S at the back index. And if there is a mismatch, if they're not the same, then we immediately return false. So this is very important to understand exactly what happens here. So if there is a mismatch, this function will terminate and will immediately return false. Nothing else in the function will execute if this were to ever evaluate to true. Okay, now so long that we don't return false, we keep updating front index, back index. We increment front index so it's moving in this direction, back index is moving in the opposite direction, and then we're guaranteed that they're going to meet at some point. They're going to cross. Now, if we go through all the comparisons and it's never the case that there was a mismatch, then we know what we have is a palindrome, so we return true. Okay, so let's run this just to make sure it works. So in this case, we're going to test it out with 2 strings. I just noticed there's a little problem here. Here we go. So we're going to check if noon is a palindrome, and we expect that to be a palindrome. So here we are, is noon a palindrome? True. Is race car a palindrome? Also true. So that's expected. And let's look at an example that is not a palindrome. So if we were to put a space between race and car, so race space car, that's not a palindrome. And if we execute, sure enough, it tells us it's not a palindrome. Okay, now as it turns out, there is an alternative method and a much easier method to solve this problem. Now, so what's the value of what we've done earlier with the first method? Well, that showed us taught us a bit about problem solving, computational problem solving. So it is very valuable to have gone through this exercise, but it's also good to see that there are much more compact ways to go about it. And the way the alternative method uses a slice operator in strings. So here's how it works. So given string s, race car, we could express the reverse of the string using this syntax, which is the colon -1. So the third element here, the -1, means we're going in the reverse direction. So this produces the reverse of a string. Now let's verify that. So if I were to execute it, so if I were to reverse, given this input race car, if I were to reverse it, I end up with the same thing. So ultimately, the problem of determining if a string is a palindrome is to determine whether the string and its reverse are the same. So that's what we're going to do. And instead of doing it manually character by character, we're going to use the slice operator to produce the reverse of a string. So what would that look like? Let's take a look. Here we have a much more compact function. So what we do is, given a string s, we're going to compare s to its reverse. And if those two are the same, this is going to evaluate to true. So this is what we return, true. If they're not the same, we return false. So this solves the palindrome problem. And we could test for it. So here we have race car without a space, which is a palindrome, and one with a space, which is not. And if we execute, it produces the right result. Okay, so third problem we're going to look at is deals with a list of integers, and the idea is we want to be able to count how many elements in the list are greater than the mean or greater than the average value in the list. Now, in order for us to do that, the first thing we need to do is to actually compute the average. Before we could count how many are above the average, we have to know what the average is. So we compute the average, and we could do that pretty easily with the help of a built-in function called sum. So given a list, if we call sum on the list, it sums up the elements of the list. So that comes in very handy. And if we were to divide the sum of the list by the number of elements in the list, we get the average value. So that's how we're going to compute the average. And then, well, if we're going to produce a count, we're going to initialize a variable count. Initialize it to 0. And then we're going to iterate through the elements of the list one at a time. Iterate by element one at a time. And then, if the element we're looking at exceeds the average, is greater than the average, then we update count, we increment count. And then when we go through all the elements, after we've gone through all the elements, we simply return the count we've produced. Okay, so let's see the solution in code. So here's what we have, function named greater than mean, but you could call it something else that's meaningful. And num list is the parameter. It's helpful to include list as part of the parameter name, so you're reminded that this function is expecting a list. And then first we compute the average by summing the list and dividing by the number of elements in the list. So that gives us the average. And at that point, we're ready to iterate through the list one element at a time. But first we initialize count to 0, and then we start iterating through num list. So for each element in num list, which we call num, we ask the question, is num greater than the average? If it is, then we update count. If it's not, then we don't do anything to count. So that doesn't need to be represented here. And then after we're done processing all the elements in the list, we simply return count. Okay, so quick example of that. Let me run this function first and then look at a quick example. So here's an example where I call greater than mean on a list. Make sure you include the square brackets here, otherwise it's not a list. So the argument is a list, and the elements in the list are 1, 2, 1, 2, 1, 2. So we know the average value is 1.5. So we know all the 2's, there are 3 2's, are greater than the average. So we'd expect that this is going to produce 3 as a response, as an answer. So let's try it out. Execute, and here we are. We have 3, which is what we expect. Okay, so one last bit of detail about functions is that function parameters and variables are local to the function. So whenever we define a variable inside the function, it can only be accessed inside the function and not outside. So this is a small detail, perhaps, but it could save us a lot of trouble in debugging if you just remember this. So here's an example to illustrate it. So here we have function compute distance, which we've seen before, and it has the 4 parameters, x1, y1, x2, y2, and distance. So those 5 variables, so what this means is that those 5 variables, parameters as well as distance, are only visible within the function. So that is their scope. That's the term. The scope of the variables is the function. So if I were to call the function compute distance, and in this case the arguments are 1, 1, 3, 3, they're not variables, the arguments could be values, of course, and I get back the result d. So d as a variable is defined outside the function. So if I were to print d, that's perfectly okay, that's recognized. But if I were to print x1, well, x1 is really defined, is only recognized in compute distance, so that would give an error. And same way with distance. Distance is a variable that's defined inside the function. D is okay, but not distance, because distance is defined in the function. Okay, so if I were to execute this, you would expect line 7 to be okay, but then we'll get an error with line 8. So here we are. And the error, it's a name error because it does not recognize the name x1, nor does it recognize distance outside the function. Okay, so with that, we've pretty much covered all the important ideas and functions. So thank you for listening.